in a disastrous place, suppose a natural calamity happened, obviously the person can't go in that case. So
how can this be used to transport goods?
No, that's...
we have to further design it so that it can hold, it can lift a weight, and that motor will lift that much weight, and so that the arms should be a little more stronger than this.
It will not put unnecessary pressure on the... Okay.
I hope that it might be a bit heavy as for the existing consideration. Existing design, it might be a bit heavy,
Yes.
considering the electrical cables are, say, 9.5 mm. I hope the electrical cables on the top side are 9.5 mm. So when you connect this one to a 9.5 mm, there, as you stated in your demerits, there will be sagging, there will be vibrations. When corona discharge is more, calamities might happen. Is there a way possible that you can reduce the weight of the system? By using ergonomic motors, by using stationary shafts or something? If it's possible, try to implement that one. Option number 1. And option number 2, I forgot. I was thinking of it, I forgot.
Oh, this runs on only one line.
Got it.
What about the other lines? So are we to assume that there will be 3 parallel bots running at the same time?
Yes, sir. If we increase the length of the arm and we connect to that.
Okay.
But for that, sir, we have to measure the distance of that, because it won't be similar in all the cases.
Between the 3 phases, if you connect, because this is for 1 phase, if you connect 3 phases, consider the effect of interference. That's a good design that you mentioned. That's really good, because you neglect the cost of 3 separate designs and you have one, and probably if it's possible you can separate, you can distribute the weight between 3 different lengths, if it's possible. In that case, consider the effect of interference. Because when you use 3 phases, and when it's up and around, for example, when you use for electric trains, 25 kVs. So 25 kVs, interference, you know the calculations. So try calculating the effect of the interference, point number 1. And my doubt was, okay, we have 2 poles. We have n number of poles. According to your design, your system can move only from one pole to another pole.
Yes,
Does
sir.
it?
Yes, sir.
Is it meaning that I have to have separate designs for...
Sir, actually, we were planning to design like it will hold the arm, but we didn't get the proper clamps for that.
This is not the end point.
Yes, sir. We'll try to develop it. Yeah.
I guess you guys are 3rd years, right?
Yes.
You still have your final years, you still have your thesis. This is a real good one. Keep working on it. Possibilities, you can get it implemented in TNE or Adani Power or Reliance. Those guys want projects like these. It's up to you to provide them with some information so that they'll give you, okay, if not they'll give you an project, they'll give you an intern. That's good enough, worthy enough. So keep working on it. It's a good one. As you can directly see, I was really impressed with your demerits, because what I was thinking after seeing your first 2 pages of your report, I was thinking, okay, these might come. You had even more than what I expected. That was impressive, because most of my presentation do not have the demerits at all. I tried to neglect the demerits. What you mentioned, all the demerits, was a really good point. So try neglecting the demerits, try scrutinizing them. So in case if you can have, I suppose it had 5 or 6. If you can bring them down to 2 or 3, try working on it. We'll expect you next year with a better result.
Sure, sir. Thank you, sir.
Me, sir?
This is the first paper that I'm seeing with two pages, two paragraphs, two columns. Huh? I'm only here. ரெண்டு காலம் இருக்கு, நான் இப்பதான் முதல் தடவை பார்க்கிறேன். இருந்துச்சா?
மொக்கதான்.
The switch. It's a tedious process for him to do so that it's very tedious process for him. It's very tedious for him to that. For every time he wants to go near the switch. On the other hand, for physically challenged people or a sick person lying on the bed or old man or old woman lying on the bed, if he or she wants to switch on the device or turn off the device, obviously he also wants to move near the switch. So he can't move at that time. In order to prevent this, we are going to have a project and a project presentation and project display here. Now I'll proceed over to K. Achaya.
Greetings. Our project is, as she said, our project is remote-based control devices. Basically, the remotes are usually used as IR sensors, but here in our project we have used the RF sensor. The reason to use RF is the RF sensor has a greater range than the IR sensor. It has high carrier frequency than the IR sensors. So next, the components of the project is, we have used the 8051 microcontroller. The microcontroller is the heart of the system. The need to use microcontroller is the chip is very less in size, so the hardware components size can be reduced, and it consists of the microprocessor, internal RAM, ROM, memory, and other peripheral devices, and it has many bit handling instructions, so it is very efficient. And then next is the 8-bit keyboard. Next is the IR transmitter receiver module, and relay, which is used in case of a heavy loads, then power loads. Then the software here we use the Kale Microvision, Flash Magic, and Proteus. But in microcontroller, it's very simple to flash the program and get the output, and it will be continued by S. Vishnu.
Explain how this project works. We have a keypad which will act as a remote and which will transmit the electrical signals based upon the key press, so that when the key is pressed, a signal is transmitted to the transmitter. The transmitter uses radio frequency transmitter. It will wirelessly transfer the signals to the receiver. The receiver can be placed at a distance of about 400 foot. It's the range of the receiver. And the receiver, based upon the input it receives, will drive the will give the input to the microcontroller. We have used an 8051 microcontroller. We'll be giving the input to one port, and depending upon the program flashed into it, it will be driving the load. In order to drive the load, if it's a heavy load, we need a driver, because the microcontroller cannot drive all the current that the device needs to switch on. So we'll be using a driver in case of motors and other heavy loads. Else we'll be using a relay to drive the load. I'll now exhibit the project. We've now used two loads. It can be extended to many loads. In case you want to drive a lamp, we'll be using a relay driver to drive the lamp. Since we burnt out the driver IC, we couldn't exhibit that. And the motor IC is working. Motor driver IC is working fine, so we could make that with the motor. And we can also use a buzzer. If the input is pressed correctly, the microcontroller will operate the buzzer also. So now I will ask Saranya to outline the disadvantages and applications.
Now let us see the advantages and disadvantages of our project. Advantages. It is very convenient, low power consumption, handling is very easy, efficient, not as sensitive to weather and temperature conditions. There are few disadvantages also present here. Interference and lack of security, which means here transmission is wireless, so signal may escape through roofs and walls. Now let us see the applications of this project. It is very useful for physically challenged people. Commands can be controlled by the controller directly, so we can use it conveniently. Heavy power load applications in industry. Now let us see the future scopes for this project. Remote control can be extended to control the speed of the fan and brightness of the light and LED also. RF transmission of electrical signals using remote controlling is very easy and convenient to use. About medium range signals only. About that, the transmission of radio waves is limited to disturbances. It does not provide proper security. Hence, the electrical signals can be transmitted through the different bands of spectrum to improve the remote control range. Thank you.
One practical application of this project will be having two mobiles instead of the transmitter and the receiver, and using a DTMF driver we can use it to control appliances also. Nothing can be referred without addressing its disadvantages. It reduces manual labor. Of course, though it reduces manual labor, we will be considering reducing manual labor as a luxury. So it is a disadvantage as well as an advantage. Yes, radio frequency controlled remotes are past due, and IR remote controls are well on their way out, even to the point that in a few years we'll be looking back with amazement and marvel at the fact that we'll be in order to power a appliance, we'll be pointing into it and shooting at it.
Okay. So you see this is wireless, right?
Yes.
But all I see are wires.
The transmission is wireless.
So you're saying that the remote is not connected to the things, right? Is that what you're saying?
The transmitter and receiver are not connected to each other.
Show me. Just lift it. Can you lift it slightly? Okay, so the transmitter and receiver are not connected in any way. Okay. So are there two independent circuits here? Are there two independent circuits? Okay, see, I'll be very clear. This is your fan. This is your light.
Can you please leave it so
This is your fan, this is your light, that's your remote. Fan and light are connected, it's okay. Why is your remote connected? You get what I'm asking?
They are
Sorry, okay.
different circuit, and the receiver is connected to the controller and the driver circuit and the load. They are
Okay.
3 transmitters and 3 receivers.
We have one transmitter.
Okay.
To transmit the signal, depending upon the key which is on the stress, we use the keypad as a remote.
Okay.
The keypad will transfer the electric signals to the transmitter, and the transmitter will transmit the radio frequency signals to the receiver.
Receiver.
The receiver, after receiving the signal, will be transmitting it to the microcontroller input. Microcontroller input, based on the plant unit, it will drive the output. Like if I have decided to press the LED, the LED will glow, and to switch off it will be pressing this key. In case if I want to drive the fan, I'll just switch this on, so that it will be on condition. And when I press this will go on.
Okay, so each time this thing transmits the signal and the receiver receives it and gives it to the microcontroller, and the microcontroller decides which device to operate. So that's it. Okay, so the connections that I see here, because of the connection of this transmitter to, what is this transmitter connected to?
The transmitter is connected to
The remote and to the power supply. That's all, right? Okay, and the receiver is connected to the microcontroller alone, is it? And the power supply. And the microcontroller is connected to all your devices. Perfect, okay. Good.
I had one question. Doesn't it seem to be a bit complicated for a wireless network?
That is exactly the point I was trying to put across.
I'll try to be simple. My wireless network should have least number of wires as possible. From a layman's point of view, this looks more a wired network. How is it possible to make it more wireless?
You can have a battery to power the transmitter and this will be a single circuit. The transmitter and the keypad will be a remote, and we can power it separately. And the receiver we can power it separately. And every controller
As I can see, if I'm not wrong, the remote, transmitter, everything is connected.
we are sending power supply to a common.
Okay. So in case if you don't have the power supply, then okay.
But we can have a separate power supplies for
But that might make it more costly then. That might, yeah, if you have separate power supplies, say for example, like a TV remote, you have a battery for your own system. If it's possible with the TV remote with 1.5 volt batteries, well and good. Is your application compatible to that? Is your application compatible to the 1.5 volts, or your application needs 9 volts or 12 volts?
We give 5 volts.
So you have 5 volt supply. What in case you can use a DC power, a battery power with 3 volts with two 1.5 in series? Is it possible? Please try to do that so that you don't have these much cables invisible, and I can say from my vision that it's a wireless system. Because when I look upon it right now, there are so many wires, I get confused, where's the transmitter, where's the receiver, and only because of the buttons I know that that is the remote. So otherwise I'm totally confused where is what. So if it has to be a wireless system, it has to have minimum number of wires. So try to make it as minimum as possible, and with the battery sources try to have 1.5 volt batteries, as much as in series as you want, doesn't really matter, because when it's 1.5 volt batteries it's just 10 rupees or 12 rupees. But when you connect these cables, it has, and particularly when it has AC source power, it makes things complicated. When it's DC, you have to think about the interference losses, the coupled losses, and all those losses, and particularly with the safety with regard to DC supply. DC is more dangerous than AC, as you might know it. So think according to all those things and try to make it a bit more compatible. Okay, good work.
Connections are correct, the circuitry is correct.